So, just recently we have seen the cardiac anatomy, cardiac cycle. Now the topic is conduction system of the heart, which is very important, equally important. At every stage of ECG reading you will need. So, this is known as conduction system. This is first year of medical student actually, but if you know then you skip it, or if you want to be revised, you may revise it. See, how heart contracts. There is a SA node. This is known as SA node. This is SA node. SA node is called pacemaker of the heart, which this SA node will initiate the impulse. SA node will initiate impulse and send the signal for the contraction of the atrium and ventricle, subsequently in the ventricle. How? Anatomy, you know, 4-chamber anatomy, we did square diagram just to understand the cardiac circulation or cardiac cycle, but heart is not square, heart is different. So, this is you know, this is right side of the heart, RA, and bloods coming from the here SVC, superior vena cava. So, SA node is situated at the junction of superior vena cava and right atrium, which is a dominant pacemaker of the heart. I will tell you why it is dominant and all that. So, when the impulse is initiated, so it will send the signal. So, ultimately next topic will come action potential, where you will know what is the action potential, and then we will go into the detail. So, now SA node will send signal for the atria, right atrium, to contract, because it is situated in the right atrium basically. So, naturally this will contract first. This is left atrium. So, SA node, which is situated in the right atrium, will contract first, and it will send signal to right atrium first and then to the left atrium. Okay. So, how? And I will, this is LV, this is LA, this is RV, this is RA. So, there is a SA node here, there is a AV node here near tricuspid wall, but it is in the upper side, right atrium only. And actually electrically, I will tell you, electrically it is only 2 chamber, atria and ventricle. Though they are 4 chamber, by electrically heart is only 2 chamber, atria and ventricle. So, this is AV node. This is also a not dominant, subdominant pacemaker. When it has some issue, it will take it over. So, this is AV node or atrioventricular node, and from atrioventricular node, there is a bundle of his, this is bundle of his, and from bundle of his, I will tell you, this bundle of his bifurcate into 2. This is right bundle and this is left bundle. So, left bundle ultimately divides into left anterior and posterior fascicle, left anterior fascicle and left posterior fascicle. So ultimately it is a two dimensional, so that is why some diagram you will see this, the people are calling this is left anterior, some will see left anterior. So it is basically this is a anterior superior division, left anterior left anterior fascicle is a anterior superior division, and left posterior is a inferior posterior division. So it covers the posterior aspect of the heart. Understood? So we have seen now left anterior fascicle. Now when this is stimulated, the impulse will spread to the atria, right atrium. There are at the same time this impulse will go to the left, it will go to the left atrium also. So, but by the means of, and from, see, three things will happen, three things. Once impulse has originated here, it will go to the LA, it will spread to the RA, because RA it is connected. So it will spread immediately to right side, but left side is little away. So there is a track. So see, if there is a wire, so it will transmit the impulse fast. No? So this is like, this is known as Bachmann's bundle, which goes from left to right to left. Now from, there is a connection between SA node and AV node. There are three intranodal track between SA and AV node. Again, because this is why there has to be wire, because one cardiac cycle takes less than 1 second, 0.8 second, the whole thing has to be over. So there are three tracks, 1, 2 and 3 intranodal tracks. So there are 3 intranodal track, anterior, middle and posterior, anterior, middle and posterior, and this is Bachmann's bundle. The name for middle track, is Wenckebach, and this posterior is Thorel. So this is conduction system of the heart we are talking about, where dominant pacemaker is a sinoatrial node, SA node is a sinoatrial node, which is a boss from where the impulse has been generated. Now it has spread to the right atrium because it is situated into the right atrium, but for left atrium impulse has to reach faster. So there is a bundle that is known as Bachmann's bundle, and there are 3 intranodal pathway from SA node to AV node. So this is anterior, middle and posterior. Middle one is known as Wenckebach and posterior is known as Thorel. Now there are 3 intranodal track, one Bachmann's bundle to the LA and this thing. So one impulse immediately reached to the AV node. So what is the duration? It is 0.03 second, 0.03 second impulse will reach here, but impulse spreading to the right atrium will spread to the normal tissue. These are the highly the velocity inside is very high, these are like electrical wires, and this is a normal tissue. So impulse in the RA spread like this, and I will tell you how impulse spread. Suppose this is the wall of the right atrium or left atrium, whatever. The impulse spread longitudinal from cell to cell, So it takes time. So how much time it takes? I will tell you the explain simultaneously now the timings also. So it will take around maximum 0.6 to 0.7 second to stimulate the right atrium. Since left atrium is away, and so the here there is a duration is little more, duration will be around maximum to maximum duration will be 0.10 to 0.11 second, but impulse is reaching to the AV node in 0.03 second, and so here there is also electrical wires, so it will another 0.04 second it will reach to the bundle branches, and from bundle branches this is a Purkinje system. Purkinje fibers, those are also a electrical connection, and then it will spread to the ventricle. So now remember what will happen, impulse reaching here in 0.03 second, whereas maximum time for the left atrial contraction or what we call is a depolarization. I will come what is depolarization, but it takes almost 0.10 second. So and from 0.03 second here 0.04 second, so total duration is 0.07 second, understood. So before the atria get contracted, the ventricle will start contracting, it will like this. So there will be a desynchronization because it has come very fast here 0.03 second, from here it has come to in 0.04 second, so total duration in 0.07 second, whereas left atrial total depolarization time is around 0.10 to 0.11 second. So ventricle, and there will be a desynchronization between atria and ventricle, which happens, which doesn't happen. The why it is, I will tell you the reason. Now this is atrial depolarization, and subsequently there is a ventricular depolarization. I told you that at impulse comes in 0.03 second here and 0.04 second to till the Purkinje system, Purkinje fiber. So but LA depolarization will be the longest, 0.01 to 0.11 second maximum. So but so in that case there will be desynchronization, which doesn't happen. I will tell you why. See this AV node I am drawing here. This is like it has three parts. This is nodal, this is atrial node, and this is AV node, and this is nodal his, because it is close to bundle of his. So it has enhanced automaticity, means it can depolarize or it can generate the impulse, this portion also, but this portion doesn't. So there is a delay in AV conduction. So where is the delay? Delay happens in this. So impulse when comes here, by the time it's come out, so from entry here to entry here, exit here, it takes almost 0.10 second. 0.10 second. So that is known as AV nodal delay, 0.09 second or 0.10 second. So this has to be added in both the two. So this, because of this portion, the impulse which comes from the intranodal tract, and when it exits the time is taken is almost 0.1 second. So that is known as AV nodal delay. Now this so this is 0.10, 0.03, 0.04. this is delay, this is intranodal track, and from AV node to Purkinje system. So total duration is almost 0.17 second. So when this SA node impulse will reach to the end of the Purkinje system, and now the depolarization of ventricle will start now. So almost the duration will be 0.17 second. So it is well above the atrial depolarization. So there will be no desynchronization. On the contrary, atrial systole, atrial contraction will take first, followed by the left ventricle contraction, because it has to be get filled. So and here almost when it reaches, two things that I will repeat again, when at the end of this Purkinje fiber, the depolarization it start from, this is endocardium, endo means inside, and this is epicardium. So I will draw here, this is a wall of left ventricle, wall of ventricle. So these are the Purkinje fibers. So impulse from SA node has come to the AV node to bundle of His, to the right and left bundle branch. After bundle branch, it has come to the final stage like Purkinje system, and from where then now depolarization start. Depolarization will start from endocardium to epicardium. That I will repeat next, how I will tell you, endo to epicardium. So almost 0.04, 0.05 seconds plus add till the depolarization takes. So almost when this portion is get depolarized, the total duration is almost 0.22 second. So here we came to end of the impulse conduction from SA node to the ventricular depolarization. So I will summarize in very brief. Impulse originated at SA node, reach in AV node by 3 internodal track to the LA by Bachmann's bundle, and impulse spread to the atrium by normal cell to cell cardiac myocyte, atrial myocyte. Now there is a enough delay of 0.9 to 0.1 second, 0.09 to 0.1 second in the AV node, and then it travels to the bundle, both the bundle, left bundle and right bundle. Left bundle ultimately divided into anterior and posterior fascicle. Anterior fascicle is antero-superior division, and left posterior fascicle is posterior-inferior division. Posterior-inferior division. So these are two fascicles. So this is one fascicle. So left bundle, whenever there is a left bundle branch, it is a bifascicular because there are two fascicles. So impulse ultimately this end divide into the Purkinje fibers, and from here the depolarization of ventricle takes. So almost it takes 0.22, 0.23 seconds till the whole cycle gets repeated. Means this is the end of depolarization. Now repolarization. So depolarization plus repolarization is a one cycle. So this is end of the conduction system of the heart.